As you see, we're back to our lab, and the link that I drew on the board was this link between router 201 and router 1. So router 201 serial 010 interface is connected to router 1 serial 000 interface. Let's go ahead and log into router 201, and let's look at the serial 010 interface. So I'm going to execute the command show interfaces serial 010. A few things I want you to notice about this interface. Now, we already know that by default, serial interfaces, or all interfaces on a router for that matter, are administratively shut down. Again, the maximum transmission unit is 1500 bytes, and the bandwidth is 128 kilobits per second. I also want you to notice that the encapsulation is high-level data link layer control. Once again, high-level data link layer control, or HDLC. So the default encapsulation type for a serial interface is HDLC. I also want you to notice that there is no MAC address on a serial interface. So serial interfaces do not have MAC addresses. So let's go ahead and assign this interface an IP address. Before I do that, show IP interface brief, just to show you that serial 010 by default is down. Now let's go into serial 010 and assign it an IP address. So configure terminal takes me to my config mode. Then I go into the interface by saying interface serial 010, and now I assign it an IP address, and we pick the 200.200.200 range, and router 201 I'm going to make .2, and my mask is going to be 255.255.255.252, which is the same as /30, total of 30 bits on in the subnet mask. So 8, 8, 8, which makes 24, and then 6, which makes 30. I'm going to bring the interface up by executing the no shutdown command. Now I'm going to go to router 1 and do the same. So enable, configure terminal. I'm going to go into serial 0, interface serial 000, assign it an IP address. This side I'm going to keep as .1, 200.200.200.1, and the mask is going to be 255.255.255.252, and I'm going to execute the no shutdown command. And as you see, interface serial 000 has been changed to up. Our link should have gone green. Let's check. Yep, it is green. Let's go make sure this interface is up. Show IP interface brief, and it says up, up. Let me ping the other end and make sure this is up. Ping 200.200.200.2, which is the IP address of router 201, and it pings. Now, you might be tempted to ask me, Junaid, you did not set a clock rate. You just told us that one side is going to be a DCE side and the other side is going to be a DTE side. And you have to set a clock rate on the DCE side. Well, first order of business, let's figure out which side is the DCE side. For this should not have worked yet. So to figure out which side is the DCE side and which side is the DTE side, we execute the command show controllers and then the interface ID, which is on this end is serial 000. And on top here, if you look, it says DCE. The V.35 is the cable type, and the DCE side has an automatic clock rate set, which is why this link went up. Nowadays, Cisco routers come with an auto clock rate on the DCE end. So the clock rate, I believe, is set to 20 million. Or is that 2 million? Well, 2 with 1, 2, 3, 4, 5, 6 zeros. Let's check the other end. On router 201, if I execute the same command with the interface ID serial 010, show controllers serial 010, you will see that this end is the DTE end, and clocks are detected, which means it detects clocking being set from the other end. So let's look at the running configuration for router 1. So I'm going to go back to my DCE side and say show running config. As you see, under serial interface serial 000, there is an automatic clock rate set already. What if I want to change this clock rate? For if I look at my interface with the show interface serial 000 command, on router 1 side is interface 000, you will see that the bandwidth of this link is 128K. So this link cannot support a bit transfer rate over 128K. So we might as well set the clock rate to match our bandwidth, for you can't go any faster than that. So configure terminal. I'll go into my interface serial 000 and execute, say, clock rate. And if I execute the help feature at this point, you will see all the different clock rates available. But the one that matters to us is this guy, 128,000 bits per second, or 128K. Type in 128000 and hit enter. Let's make sure the clocking has changed on the interface. So do show interface serial 000. And now, oh no, it's do show controllers. Do show serial 000. And now we will see that the clock rate has changed to 128000. Now, at this point, if we look at our do show IP interface brief command, I see that the interface is up. Now, what happens if I change the encapsulation type on one end? That's what I meant earlier by mismatched encapsulation. On router 201, which is the other side, we already know by default the encapsulation is HDLC. And on router 1, also, the encapsulation by default is HDLC. Right here, under the show interfaces serial 000 command, you see on both sides, on router 201 and router 1, the encapsulation by default is set to HDLC. What happens if I change router 1 to something else? Well, let's see. I will change the encapsulation type to, there are three options here: frame relay, HDLC, and PPP. I'm going to change it to frame relay. Let's look at our show IP INT brief command again. And you see that the interface has changed state to up-down. So that is our first layer 2 issue. Now, I can't really get rid of the clocking on this interface because it's there by default. So if I get rid of, if I say no clock space rate 128000, so if I do this, well, let me change the encapsulation type back first to HDLC. and you see that the link went back up immediately. Now, if I try to take the clock rate away by saying no clock rate, and I then check do show controllers serial 000, if I can spell and type, we will just leave it at S000. See, I cannot take away the clock rate. It is set by default. It should have actually gone back to 2 million, but on Packet Tracer or even on real routers, you really can't take away the clock rate. If I look at my running config, the clock rate does not go away once it's set. So if I were to take away the clock rate, you would again see an up-down situation in the show IP interface brief command. The last option is that if router 1 stops sending keep alives. So if I execute the no keep alive command, the link should go down in a little bit. But we're not going to wait 5 minutes for this to go down. You just take my word for it that if I turn off keep alives, or if there is an error, oh, see, it did go down actually. So let's test that out again. No keep alive. And let's execute the do show IP interface brief command. Well, it shows up, but the link is technically down. If I say the keep alive command again, do the keep alive command again, it shows that line protocol came back up. So which meant it was down previously. So if you see an up-down situation in the show IP interface brief command, there are 3 possible reasons, and all 3 are layer 2 issues. Keep alives are missing because the interface is malfunctioning for some reason, or there is a mismatch encapsulation between your side and the other end, or the DCE side has no clock rate set. I'm going to save my work on router 1 and router 2 so we do not lose it. And we are going to move on to IP routing theory. This concludes the lab.